The diagram shows a rectangular box having a square base with side x. These sides are x. The box has a volume of 2 multiplied by square root of 2. The diagonal AH has a length of x plus 1. If x can only have integral values, what is x? Let the height of the box AE be h. Diagonal of the lower face EFHG, that is E, F, H and G, is EH, and that is equal to square root of x square plus x square, because the sides are both x, and that is equal to square root of x. So the diagonal of the lower face is square root of x. In triangle A, E and H, angle AEH is 90 degree. That angle is shown here. This is 90 degree. Therefore, AH square is equal to AE square plus EH square, and AE square is H square and EH square is square root of 2 into x whole squared. So AH square is equal to H square plus 2x square. It is given that AH is equal to x plus 1. Therefore, x plus 1 whole square is equal to h square plus 2x square, which we just now found out. Now, x plus 1 whole square is equal to x square plus 2x plus 1, and that is equal to h square plus 2x square. By rearranging terms, we get h square is equal to minus x square plus 2x plus 1, or h is equal to square root of minus x square plus 2x plus 1. Volume of the box is the area of the bottom face, that is EFHG multiplied by the height h. So it is volume of the box is h into x square, and that is given to be 2 multiplied by square root 2. So because h is equal to this much, we get square root of minus x square plus 2x plus 1 whole multiplied by x square is equal to 2 multiplied by square root of 2. Squaring both sides, we get minus x square plus 2x plus 1 multiplied by x square is equal to 8, or minus x square plus 2x to the power of 5 plus x to the power of 4 is equal to 8. Multiplying both sides with minus 1, we get x to the power of 6 minus 2x to the power of 5 minus x to the power of 4 is equal to minus 8. Now on the left hand side, if you take x to the power of 4 common, we get x to the power of 4 multiplied by x squared minus 2x minus 1 is equal to minus 8. Let us call it equation. Again, equation 1 is x to the power of 4 multiplied by x square minus 2x minus 1 is equal to minus 8. Now it is given that x can only be integers. So, since both terms on the left-hand side of the equations 1 are integer, the right-hand side of equation 1 has to be the product of two integers only. That is, we know that x to the power of 4 is an integer for all values of x. Similarly, x square minus 2x minus 1 is also an integer for all values of x. So the left-hand side is the product of two integral values, and therefore the right-hand side also will be the product of two integral values. This restricts minus 8 to be the following products only, that is minus 1 multiplied by 8, or minus 2 multiplied by 4, or minus 4 multiplied by 2, or minus 8 multiplied by 1. Now x4 can never be negative. Therefore, x4 can only be the positive values, that is 8 or 4 or 2 or 1. But x has to be an integer. Since x to the power of 1 by 4, 4 to the power of 1 by 4 or 2 to the power of 1 by 4 are not integers, the only value possible for x is 1, because x to the power of 4 will then become 1, which is an accepted value. Before going any further, please like, subscribe, share and hit the bell so that you can be immediately notified for new uploads. It is completely free and only takes a few seconds. You can always unsubscribe later. Without further ado, let's proceed with the rest of the video. The second term on the left-hand side is x square minus 2x minus 1, and this term has to be equal to minus 8. Or for x is equal to 1 to be a valid solution, it should also satisfy the equation x square minus 2x minus 1 is equal to minus 8. When we plug in the value of x is equal to 1 in this equation, we get an absurd result of 1 minus 2 minus 1 is equal to minus 8. This means that there is no integral solution or integral value for x, and that is the answer.